Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 2nd, 2025, just 2 days ago. This paper tackles a big problem with what are called reward models. A reward model is basically an AI that learns to predict what humans prefer, helping to guide larger models. The authors here created new ones that are so effective, their small 1.7 billion parameter version beats many existing 70 billion parameter models. The paper is titled Skywork Reward v2, Scaling Preference Data Curation via Human AI Synergy, and it really shows that data quality, not just size, is what matters. Also, the authors shared their work on GitHub. If you check it out, you'll find links to all 8 of their reward models, along with detailed benchmarks and usage recommendations. They even provide code snippets for inference, making it really easy to get started and experiment with the models yourself. Over on Hugging Face, you'll find their collection of reward models, with weights available from a tiny 0.6 billion up to the 8 billion parameter versions. Alright, and to see just how well these new models perform, let's look at the first figure. This bar chart lines up their top models against previous state-of-the-art reward models. The comparison happens across 7 major benchmarks, which are basically standardized tests that measure how well a model can judge things like general human preferences, safety, and even factual correctness. Well, the results are pretty clear. The new Skywork Reward v2 models, shown in the bright blue, teal, and orange bars, consistently score higher than the older models across the board. Building on that, this next figure really drives home why using multiple benchmarks is so important. The scatter plot on the left shows that the Skywork reward models, those blue and teal dots, consistently score high across both the older reward bench and newer tests. In contrast, other models are scattered, showing that good performance on one benchmark doesn't always translate to others. The heat map on the right explains this, showing the correlation between different tests. A low correlation, shown in red, means the tests are measuring very different things, which highlights the brittleness of evaluating models on a single benchmark. So the big question is, how did they achieve such robust and consistent performance? Well, this diagram lays out their clever 2-stage pipeline for curating data. The first stage is all about human and AI synergy. Humans create a small, high-quality gold set of preferences. Then, an AI model learns from this and gets tested. A key step here is adaptive retrieval, which is a smart system that finds new data similar to where the model made mistakes. The second stage then automates this, scaling up to millions of data pairs without more human help. And that meticulous data curation pipeline really pays off, as we can see in this next table. It breaks down the performance of their Skywork reward models against a whole host of others, including existing open models and even large language models used as judges. Across 7 different benchmarks, the Skywork models, listed at the bottom, just dominate. You can see all the bold numbers, which mark the top score in each column, are almost all in their section. Their largest model achieves a stunning average score of 88.6%, far ahead of the competition. And these next charts really get to the heart of why their method works so well, through a set of ablation studies. These are experiments where you remove parts of a system to see what each one contributes. The left plot shows that using just the original, uncurated data, that blue line, doesn't improve things much. But with their filtering and correction method, the green and orange lines, performance steadily climbs. The right plot is even more striking. It shows that with just 1.8% of their high-quality data, their model already surpassed previous top models. And this next chart provides an even clearer breakdown of which parts of their curation method matter most. You can see that starting with no curation, or even using raw LLM curation, gives a score of around 71. So just throwing an LLM at the problem doesn't really help. But when you bring in human curation, the score jumps significantly to 73.3. And then, adding their adaptive retrieval method on top pushes the score even higher to 74.2. That's the smart system that finds data similar to where the model previously failed, really letting it learn from its mistakes. So, to wrap things up, what this work really demonstrates is the immense power of high-quality data. Their clever human and AI pipeline shows that curating the right data is far more crucial than just scaling up the quantity. The result is the Skybrook Reward version 2 models, which act as better judges of human preference. These reward models are a key part of reinforcement learning from human feedback, a powerful technique for aligning LLMs with our values. This research provides a clear roadmap forward. That's all for today. I'm Alex, and this has been the AI Research Roundup.